Hey everyone, welcome back to the Config Bench. I'm John, and if you've been following along, we've covered tools, we've looked at schematics, and we've talked about components. But today is the day that we're actually going to build something. You should have a notepad and notepad and pencil, and get ready. This segment is about a breadboard, and we are about to examine a breadboard. This is a breadboard. By the end of this episode, you're going to know exactly how it works, what's happening inside, and you'll be going to wire up your very own for your first circuit and then measure it. So let's get into it. First things first, what is this thing? A breadboard is a reusable platform for building circuits without soldering. Everything just plugs in and pulls out. It's how we are prototyping. Now, it looks like just a bunch of holes, but there's a very specific pattern to how these holes are connected underneath. And once you get that, everything makes sense. First off on this board are the power rails. There's a set of power rails up here and a set of power rails here. This is how we deliver power. If you notice, there's a plus and minus up here. There's a plus and minus down here. This power rail is not interconnected with this rail, but this positive connection is not connected to the negative connection. So I can apply my battery, for instance, into the positives, here using a jumper wire, and I can apply my negative into here using a jumper wire, and we'll be doing that. These jumper wires then extend down to the area here, and this is where we would put our components and other jumper wires. The column groups. This area here represents the column groups. The middle section is where a circuit lives. The columns are numbered. On a small board, you'll see the columns 1 through 30. This is a small board. You see the numbers here. Where are they? 1 through 30. On a larger board, it goes from roughly 1 on this side. So if I had it upside down, 1 on this side to about 65, I believe, up here. In addition to the columns, there are rows labeled A through. The columns are numbered on a small board, and you'll see 1 through 30. Medium boards go up to about 65. My Mechatronics board is actually a combination of larger boards, and that's this board back here. You can see how big the surface is of that guy, and it allows for very complex breadboarding to take place. A through E is the top half, and F through J is the bottom half. Each row, so each column, for instance, column 1, this column here, these are all interconnected. Column 2, column 3, column 4, so on. That column, they're all connected. They are not connected in the lower half. So column 1, A through E, those are all connected together. Same thing with 2, A through E. Those are all connected. Now, column 1, F through J, they're all connected, but F through J is not connected to A through E. So anyway, this sounds complicated, but it's rather simple. And we are going to be building out a circuit that will demonstrate that. We are going to be using resistors. For this particular lab, we'll be using 2 resistors. This is typical for I think it's a 1 amp resistor. Not worrying about color codes right now. These are 47 ohm resistors. The color codes, if you notice the colors, all the bands that are, here. If we get out our book and look at it, there is a diagram that would show us what each band represents, and ultimately you could determine the value of this resistor based on the colors of these bands. And let's do a little bit closer here. And there it is. That's a typical resistor right there. We'll be using 2 of them, and we'll be interconnecting them in series by the time this lab is done. That's resistors. Our batteries. This is a typical 9-volt battery. There is a positive side to this battery. The negative side is never labeled negative, but it is negative. This should be a 9-volt battery, but because I've had this battery in my desk drawer for an extended period of time, it's coming out to about 7.2 volts. And so when we do our calculations, we just need to keep note of that. Jumper wires. We've got a few jumper wires here. You know, I chose black and red just simply because we got a simple circuit. These jumper wires, if you notice the pin on the end here, that pin will actually fit into the breadboard. And then the other pin, the other end, will allow us to attach a clip lead or something like that. So we have jumper wires. We have got alligator clips. You know, this is another jumper wire, and on the end of it, it's got what is called alligator clips. If you pinch it, it'll grip onto something. So there's a typical jumper wire. What else do we have here? We have the cabling that we will use to connect the battery. If you notice, it's got typical 9-volt battery connector, and then it's got a little battery connector on the other end. That's how we will be interconnecting the battery to our breadboard. Let's talk about those. So here are these little USB powered kind of circuit boards that you would plug into a breadboard. And what these allow you to do is plug a USB connector in here that supplies either 3 or 5 volts. And then this gets plugged in. If you notice the connectors, they go into the power areas of the breadboard. So if it was all plugged in and I powered up a USB, or I plugged a USB cable in, that would power, the power that we would need, in the breadboard. These can be very handy if you don't own a power supply, if you don't want to go through batteries all the time, and you're using a lab that is low power, 5 volts or 3.3 volts. And that is that. So let's build lab 1. Get these things out of the way. We're going to choose the first resistor that we're going to use for this lab. I am going to, okay. So I am going to choose a breadboard, and that will be this guy. And I need either needle nose pliers or tweezers, where I am going to take and create a 90-degree angle bend, just like that. And like that. Now I said I'm going to take this 47 ohm resistor, and there it is. It's all bent in the proper shape. And I'm going to put it in column 8E and the other leg into 12E. So I have plugged it into row E. If you notice here, I'm row E, and there's a column 10, 9, 8, so 8E, and I am all the way over in column 16, row E. It is 8E over to 16E. That is now got our resistor in place. Jumper wires. Run a red jumper wire from the 8A. Okay, so now we're going to install a couple jumper wires because we got to get it over to the power. And so we're going to use red as the positive. So I am going to go to column 8 and plug in. And then I'm going to jumper that over to the power rail. So that is now jump it over. I'm going to use black as the negative side. And that is in column 16. And I'm going to jumper that over to the power rail on the negative side. And just to do a close-up so you can see that all I'm doing is putting jumpers so I can extend the power over to the resistor. Pretty straightforward, pretty simple. Now we've got the jumpers in place. Thing is, I'm using red and black, and those are standard for power being positive, red, and negative, being black. But you can use whatever color you want. Doesn't make any difference at all. Now, DC 9-volt battery. We're about to hook up the 9-volt battery. So here is the 9-volt battery, the power connector that we are going to put on. This shouldn't be new to anyone. This is just plugging this connector directly on. The other end of this is here. And we'll plug in there. And so anyway, there's the power, 9 volts of power. I'm just going to place that off to the side for the moment. And now we're going to interconnect to the amp meter. So the power is going to deliver positive. Positive is the red. And we are going to go to the positive side of our amp meter. Screw it down on top of the bare end of this lead. So there's that. And the positive, let's see, I want to use so the negative power is going to go into the negative of the breadboard. And we're just going to insert that right in the hole there. There it is. It's now inserted in the hole, as you can see. And we need to jumper from the negative of the amp meter to the positive of the board. So I just installed this jumper, and I'm going to use this clip lead to jumper from the negative of the amp meter to what is the positive of the breadboard. And it is done just like that. So now, if you notice, what we've just done is we've applied power, and as soon as I connect it, we will have applied power to our little circuit. And as soon as I do that, I'm going to do a close-up of the amp meter so that you can see that the amp meter will start to change its value it's currently at, and you'll see the needle go up to about 160 milliamps when I connect it. And we'll do that in a minute, but first we're going to attach the leads of my voltmeter. And so what we want to do is we want to test voltage, and there's a positive and a negative side of this circuit, And so the black lead goes to the negative side. The red lead goes to the positive side. And now I am going to turn my voltmeter on. So there we go. We got the voltmeters turned on. And I am about to connect power. And I think when I connect power, there it is. I don't know whether you saw it, but the amp meter is up at about 175 or so milliamps. And the voltmeter is now reading 7.6 volts. Again, that's a 9-volt battery. Here it is. 9-volt battery, but because it's been sitting in the drawer so long, that is a symptom that you're going to see, is that when batteries start to go old and they're not doing their job, they will start to lose voltage and lose current capability. Let's talk about what we're seeing. The amp meter, I've chosen an analog meter for this lab. So if you notice over here, this is known as an analog meter because it has a needle on it. And we saw that needle go from 0 all the way up to about 180-ish amps. Is it as accurate as our digital voltmeter? It's a very accurate meter, but it doesn't have a nice, crisp, clean readout like a digital voltmeter. But I wanted to expose you to both, so you can see what an analog meter looks like. These are fairly cheap meters. They're about 14, 15 bucks. I have 2 of them. One measures amps and one measures milliamps. This particular analog meter measures negative 500 milliamps all the way up to positive 500 milliamps. And then the amp meter, same, looks identical to this, except it measures anywhere from 0 to 3 amps. My digital voltmeter, the OWON, my desktop digital voltmeter, it is currently measuring DC volts. It's capable of measuring voltage, resistance, current, AC volts, DC volts. It can measure capacitors. It can measure frequencies. It can measure diodes, and it can do a whole lot of other things. So that is that. It's a good time to talk about Ohm's law. Ohm's law, and there's a formula called V equals I times R, where V is voltage, I is current, and R is resistance. With that formula, we could figure out, and we demonstrated it a bit in our schematic presentation the other day. That's the foundation of electronics. So if you're not familiar with Ohm's law, I'm going to say, that's something that you should read up on and study on, because it's going to be referenced quite heavily. Let's see. So I'm about to take and add a second resistor in series with here, and what we will see when I do that, so I'm going to pause the video here and get that set up, and what we will see is that the current will drop because we're increasing the resistance, again back to Ohm's law, and that's it for now. Let me go build that out and I will be back. Okay, I'm back. I've updated the breadboard. I've added another resistor, so we can see that we've got the second resistor added over here. So here's the original resistor here. New resistors over here. Voltage meter is connected from the positive side of the original resistor, and now is connected to the negative side of the second resistor. And we are about to take and turn power on. I'm going to adjust this screen a bit and zoom in so that we can see the needle, how it reacts, and what's your thoughts? Should the needle increase to more milliamps than there were or less? And think about that for a second. Maybe stop the video, pause it, and do some math, because we now have two 47 ohm resistors in series, the same voltage, approximately 7.2, and you should be able to use Ohm's law and figure out what the voltage from the top to the bottom is where we're currently connected. But then when I connect to the midpoint, what do you think the voltage will be? And do you think the current is going to be? Here we go. So if we look closely at the meter, amp meter is now showing slightly less than 100 milliamps. So we went from about 160 milliamps down to a little over 90 milliamps right now. So our current has decreased because our resistance has increased. Our voltage, if it's changed, is just because it's an old battery, but we're currently at 7.8 volts DC. So I'm going to zoom out, and I'm going to change that we're currently measuring across the entire two resistors. I'm going to go to the midpoint and watch what our voltmeter does here. It goes down to 3.9 volts DC. And again, the current hasn't changed. So we're over there looking at the current. That hasn't changed. Now we're at 3.9 approximately volts DC. And so it begs the question, why isn't it exactly half? Because if it's 47 ohm resistor, half of 7.2 should be about 3.6 volts, but we're at 3.8. So why is it not exactly in half? And there are things called tolerances. In every electronic component, if you buy cheap stuff like I bought for my lab here, the tolerances can be up to 5% tolerance. So if it's 47 ohm resistor and there's a 5% tolerance, its values, and I believe that they could be plus or minus 2%. And so when you start seeing like 3.8 and it really should be 3.5 or 3.4 or 3.3 volts, go measure your resistors, go measure your voltages, just measure everything, but also realize there are tolerances that the equipment is going to. We've added the second resistor, we've extended the circuit, we set the jumper wires, as you can see. We've moved this one around from over here to here. We've seen the voltage shift from 7.2 to almost half of that. We've talked about variances of what the variances are for, or the tolerances are for components, in this case the resistors, and also for my meters. There's a certain tolerance level that they are going to be allowed to differ. That is our first lab. I'm calling it lab 1 and lab 2. Lab 1 being the single resistor, lab 2 being the dual resistor. I think this pretty well wraps up our first lab, building a breadboard circuit and exploring a series DC circuit. Congratulations, if you've done this along with me. You've just built your first breadboarded circuit. Job well done. You've done that along with the TheConfigBench. A couple of things before I let you go. To assist in my delivery of this material, I'm using a book called The Complete Electronic Self-Teaching Guide with Projects. I get nothing for this, but this is the manual that I am using, It helps guide me along, and I'm going to be going through this chapter by chapter with you, building out the labs. This is a very professionally well done delivery of the theory behind electronics and all the things that we are currently working on. If you look, we're going to go chapter by chapter. If you look in chapter 1, it deals with DC circuits, and it explains the theory, the theory of Ohm's law, the theory of electricity and current. I highly recommend that you go buy this book. So it's a great resource. My goal is to bring the practical side, the real world side, onto the bench, and complement the knowledge that's being delivered in that book. Now let's talk about a giveaway. Each month I'm giving something away. This month it's an oscilloscope made by FNI RSI. And this little oscilloscope is a great addition to anyone's bench. So if you follow along and watch and subscribe, you will be eligible to win this. So how do we win this? To qualify, watch all the episodes posted this month regarding Chapter 1. Subscribe to the channel. I'm going to be developing a set of questions so that you will need to answer the questions, and you'll need to explain your answers. And if you're the first one to do that, then you will be the winner of that little oscilloscope. Let's see, coming up next week, I'll be introducing 2 more resistors wired in parallel with our existing circuit and adding an on-off switch. I think about this before that episode happens. How will adding a parallel resistor affect the current? How will it look on the voltmeter? Do you know what parallel means? Can you figure it out using Ohm's law? Drop your prediction in the comments. I'd love to see your thinking. Also, keep an eye out for a brand new segment I'll be introducing to this series called TWD. First one is coming out soon. You'll want to watch for it. So thanks for joining me here at the Config Bench. I'm having fun, and I hope this does it for you too. Subscribe, hit the like button, comment on what you like. Feel free to comment what you don't like and what you'd like to see. See you all next time.